Hello, my name is Professor Niazi. Today we're going to be talking about the unit circle. I want to be able to explain to you so that you understand the unit circle. Many students tend to like to memorize it and they go away from actually understanding it because they believe it's worthwhile to just spend the time to memorize it instead of actually understanding it. However, I'm going to show you that once you find the few patterns inside the unit circle, that it's actually not very difficult to understand it and to derive it for yourself. Furthermore, this method of understanding allows you to truly get what's going on and the fundamentals of the subject versus just memorizing just to get by. Such a difference of knowledge will be very helpful and useful for more advanced mathematical classes like calculus. So let's start with the unit circle. The unit circle is exactly what it's called. It's a circle of unit radius. Alright? So if I get a line and I start at the origin here and I extend and I intersect the arc of the circle, at this point, if I were to create a right triangle, the hypotenuse of the right triangle, what we'll denote as capital H, is a unit value. Now, because this is trigonometry, we must associate an angle to this. And I will first associate one of the special angles, the first special angle, 30 degrees. The unit circle has a pattern in which it moves from 30 degrees, 15 degrees, 15 degrees, 30 degrees, and it repeats this pattern. What do I mean by that? Well, after we erase the fact that we know this hypotenuse has length 1, we can now draw the rest of the special angles. This is at 30 degrees, and in radians, that's equivalent to, you guessed it, pi over 6. This right here is at 45 degrees, 45 degrees, and in radians, you guessed it, that's pi over 4. Notice that these calculations can be done, as we'll discuss here in a little bit. And the next special angle is at 60 degrees, which in radians is pi over 3. And we have the 90-degree angle, pi over 2. What I mean by the 30, 15, 15, 30 rule is that from 0 degrees, when you add 30 degrees, you trivially land at 30. But from 30 degrees, whenever you add 15 degrees, you'll go to, you guessed it, 45 degrees. Add another 15 degrees, and you guessed it, you go to 60 degrees. What happens when you add 30 to 60? That's right, you go to the last special angle in the first quadrant, pi over 2, which is at 90 degrees. Now, this pattern, 30, 15, 15, 30, continues to repeat. This is just in the first quadrant right here, but this pattern repeats in all 4 quadrants. And we will conduct the calculation through all of the quadrants. If you are able to do on your own what I'm doing here, nothing in trigonometry will be confusing anymore. All of it will make sense because you are able to fundamentally derive all of the points of the unit circle and the associated sine and cosine values at those points. So, we all know that if we want to convert something in degrees to radians, let's say 30 degrees, we can use the handy-dandy conversion that in 180 degrees, there is a single pi radian. Do this calculation and we will find, once we cancel out the units for degrees, we'll find that actually this is equivalent to, you guessed it, pi over 6. Hence why at 30 degrees we have pi over 6. Furthermore, if we do this again for 15 degrees, when we cancel out the degree units, we notice that 15 degrees is equivalent to pi over 12. So 30 degrees is equivalent to pi over 6. And 15 degrees is equivalent to pi over 12. keep this in mind when we derive the rest of the results. So I'm going to erase this little leg here, because for now we're not going to be creating triangles. The associated sine and the cosine values will be done in the next video. For now, we just want to derive all the points on the unit circle. So let's continue. After we get to pi over 2, what is the next special angle? And what is the next special angle? And what is the next special angle? That is the question. Because we know over here, we're at half of a circle. And the whole circle is 2 pi. Therefore, at half a circle, we will be half of 2 pi, which is just pi, which is equivalent to 180 degrees. Notice that that is why this ratio is true, because this is really a fancy number 1. Pi radians over 180 degrees is really a fancy number 1. That's why we can multiply times things and convert the units. Now, from pi over 12, we're going to repeat this pattern 30, 15, 15, 30. Let's do it. I want to add 30 degrees to my pi over 2. And that's equivalent to adding pi over 6 to pi over 2 to discover what the next value is. Because we don't memorize, we understand. Now, to add pi over 6 plus pi over 2, we have to ensure that they have the same denominator. So I will multiply top and bottom here by a fancy number 1, which is 3 over 3, which will ensure that they are both divided by 6 now. So we'll have pi plus 3 pi all over 6. This is equivalent to 4 pi all over 6. This is equivalent to 2 pi over 3. And you guessed it, that's the value that goes here, 2 pi all over 3. And, you know, we're not going to talk about how many degrees that is. It's clearly 120 degrees, because 90 degrees plus 30 degrees gives me 120 degrees. But in the discipline of trigonometry, we typically like to work in radians. And so we'll just keep the value of the degrees in the back of our minds for now. We're just going to work in radians. Next, we follow the 30, 15, 15 pattern. And so to 2 pi over 3, I have to add 15 degrees. And the degree analog to 15 degrees is pi over 12. So I got to add a pi over 12 here. Got to multiply top and bottom here by a fancy number 1 so that they have the same value in the denominator. Right here, the number is 4. The required number is 4, because 4 times 3 is 12. And so I'll get everything over 12, and I'll have an 8 pi plus a pi. This is equivalent to 9 pi all over 12. This reduces to, since 12 is really 3 times 4, we can cancel out a 3 from the top and the bottom, and I get, this is a 3 pi over 4. Now, we did 30. 15, then what's next is another 15. So I have to add the 15 degree analog to 3 pi over 4. I'll rewrite 3 pi over 4. And the 15 degree analog is pi over 12. We've calculated this already. I'll multiply the top and bottom here by a fancy number 1, 3 over 3. So I'll get 9 pi plus a pi all over 12 is equal to 10 pi all over 12. This reduces to 5 pi all over 6. This is what will go right here. And we already know what the next value is going to be. It's going to be pi. This makes great sense, because what happens when I add a pi over 6 to a 5 pi over 6? It becomes a 6 pi over 6, which reduces to pi. That's how we get this. Next, we'll move on to values in the third quadrant. Here we're going to derive the special angles here, and we'll actually end up deriving the special angles in the fourth quadrant as well. So after pi, I'm going to have to move on here. You have this information in your notes now, because you're carefully taking notes. You're not on your cell phone. If you are a student in my class, you know I have a no technology policy. But since you are at home, you better not be on your phone. You better be paying attention, because you can learn this stuff. Mathematics was invented by human beings. And last time I checked, you're a human being. Unless you're a kind of animal who has learned how to act you know, like a dog or a cat, maybe you've learned how to access the internet. And if that's the case, woof woof, meow meow. But anyways, back to the mathematics. After being funny, we're going to add 15, 15, 30, 30, 15, 15, 30. This is the pattern. I'll rewrite it right here. So we have to add another 30 to pi. And the 30-degree analog in radians is pi over 6. So we're going to add pi over 6 to pi. This is equivalent to 6 pi plus pi all over 6. This is equivalent to 7 pi all over 6. This is the value right here. Next, to 7 pi over 6, 30, 15, 15, 30. So we're at the first 15. We have to add a 15-degree analog, which is pi over 12. Then this breaks down to 14 pi plus a pi all over 12. And this becomes 15 pi all over 12. Okay, 15 pi all over 12. Well, what does that reduce to? Well, 15 is 3 times 5. And 12 is really 3 times 4. The 3's cancel. This reduces to 5 pi over 4. Now, we get our 5 pi over 4. 30, 15, 15, 30. So we've added the first 15. Let's add the second 15. It's another pi over 12 addition. By now, you should have realized that adding degrees is what is adding angles is what's causing us to move. This is what is causing us to rotate. So we're rotating another 15 degrees on the circle. And multiplying top and bottom here by 3, I get 15 pi plus a pi all over 12 is equivalent to 16 pi all over 12, which is equivalent to 8 pi over 6, which is equivalent to 4 pi all over 3. 4 pi all over 3. And over here, if you typically gonna memorize things, the best thing to memorize is what is it here, what is it here, what is it here, what is it here. Most of you who take the memorization route will know that this is at 3 pi over 2. Another way to think about it is if this is at 2 pi, then if we're here, we are actually 2/3 of the way. So 2/3 times 2 pi would give us 3 pi over 2. I'm sorry, did I say 2/3? I meant 3/4. 3/4 of the way there. So 3/4 times 2 pi would be 6 pi over 4. And this reduces to 3 pi over 2. My apologies about that mistake. However, that's not the only way to derive it. Notice when we add the 30-degree analog to 4 pi over 3, which is pi over 6, we get 4 pi over 3. We add a pi over 6. This is equivalent to, when I multiply top and bottom by 2, this is 8 pi plus a pi all over 6. This is 9 pi all over 6. This becomes when I cancel out a 3, 3 times pi all over 2 times 3, cancel out the 3's. This is equivalent to 3 pi over 2, as we have written over here. Now we'll do the last angles. So I'm going to erase this subpart of the board here, where we'll leave the 30, 15, 15, 30. That's the only thing you really need to memorize, 30, 15, 15, 30. That is the pattern that the special angles follow. So at 3 pi over 2, I add 30 degrees, which is pi over 6. This is equivalent to 9 pi plus a pi all over 6, which is equal to 10 pi all over 6, which is equal to 5 pi all over 3. That's what goes here, 5 pi all over 3. Next, I add another 15-degree analog to 5 pi over 3 plus pi over 12. Multiply top by 4, I get 20 pi plus a pi all over 12. This is equal to 21 pi all over 12. This is equal to 3 times 7 times pi all over 3 times 4. Cancel out the 3. This is equivalent to 7 pi over 4. Next, the second 15-degree rotation. So 7 pi over 4 plus another pi over 12 is equivalent to, multiply top and bottom by 3. I get 21 pi plus a pi all over 3. This becomes, oh, I made an error, computational error. Multiply top and bottom here by a 3, I get 21 pi plus a pi all over 12. This becomes 22 pi all over 12. This reduces to 11 pi all over 12. Pi is everywhere. I'm getting hungry. Now that we are, 11 pi over 12 reduces down to, it's not going to be over 12. 22 is equivalent to 11 times 2 times pi. And 12 is really 3 times 4. And 4 is really 2 times 2, so I cancel out one of these 2's. So I get this is 11 pi all over 6. That is corrected here. All right. And last but not least, we know we get to 2 pi. How do we know that that's 2 pi? Notice that 11 pi over 6 plus pi over 6 becomes 12 pi over 6, which reduces to 2 pi. I'll write that out. 11 pi over 6 plus pi over 6. And pi over 6 is our 30-degree analog. This is equivalent to 12 pi over 6, which this reduces to 2 pi. And we're at 2 pi. Give yourself a pat on the back, because if you followed me so far, you are well equipped to be able to understand the unit circle at all the special angles. Now you're able to derive all the special angles, which is the first step towards the understanding behind the unit circle. In the next video, we'll be talking about evaluating sine and cosine at these special angles. Thank you very much.